Introduction. I'm indeed thankful to the Vice Chancellor, Mr. Wahab, and HOD of Civil Engineering, Dr. Supia Khatu. Actually, Saeed was in contact with me for a long time, and we were just, thinking about that how we can find an occasion where we can interact with the students and the colleagues at large. As he has said that I'm working in this domain for a long time, so this is also a passion for me to talk about the Indian space program. One and another is you all might be aware. Saeed, I'm audible?
Yes, sir. Yes, sir. Yes, sir.
Thank you very much. Second, you know that when we are talking about the Indian space program, we as a nation, we are second to none in the applications of advanced technologies. So that is how we see the things. I will just share my screen and then we will go ahead. So just a moment, I will just take a moment. And by that time, I would like to, greet you each and everyone on the occasion of National Science Day. As you all know that National Science Day is being celebrated in the memory of the Raman effect by C.V. Raman. So I hope that my presentation, my screen is visible.
Uh,
Yes, sir.
So this year's theme for the National Science Day 2024 is the indigenous technology for Viksit Bharat. So keeping this in mind, I will be talking to you and I will be discussing you that how the Indian space program has seen what it is today. So we will try to understand that how the Indian space program was started and where we are today and how we look for the future. As you all might be aware that Indian space program, when we are talking about a gamut of issues, meaning thereby that it must have the launch vehicle program, it must have the satellites into the sky, and it must have the data reception center. So whatever satellites are there to take these satellites into the space, you require the launch vehicle. So we will be talking about all these three facets of the Indian space program. But before it came to existence, who was the man who was behind this Indian space program? Similar to today, when we are talking on such a pious occasion in the memory of Raman effect by C.V. Raman. And you also might be aware that today is also the death anniversary of first president of India, Dr. Rajendra Prasad. So there was a man known as, you can see on your screen, in the name of Dr. Vikram A. Sarabhai. I say that he was an institution in himself. And he was, when India was venturing into the space technology, there were not many criticism, specifically from United States of America and other countries. And they were thinking that because a space program need lot of money. So if India is venturing into this area, then he has to cut the money from other sectors to develop a space program. And they were of the opinion that India is having a lot of problems related to poverty, unemployment, and so on and so forth. But he was very, Dr. Vikram Sarabhai, at a very young age, he was one of the founder member of PRL, Physical Research Laboratory, Ahmedabad. He was the founder member of Indian Institute of Management, Ahmedabad. He was the first director of Space Application Center, Ahmedabad, and he was the man behind when he discussed the issue of formation of Indian National Committee for Space Research in the name of INCOSPA, with the discussion with the then Prime Minister of India, Prime Minister Jawaharlal Nehru. So in 1962, he was able to get it formed. So he was of the opinion that if we have to play a meaningful role nationally and in the community of the nations, we must be second to none in the application of advanced technologies to the real problems of mankind and society. He was saying that we are not having any fantasy to compete with the economically advanced nations. But yes, we do have a large land mass, and to tackle that, we require a lot of, you can say, indigenous technology. So when we are talking about the mandate which was given to Department of Space, Government of India, the basic idea behind it that we must develop the capabilities, indigenous capabilities for the launch vehicle program. And then fabrication means manufacturing of the satellites, both the communication as well as the remote sensing satellites in India. Then research and development in the space sciences to reduce the launching cost, and then the capacity building means that we must have the trained manpower so that we can utilize whatever resources are available to us. So as you see here on your screen, that we are having two different type of the satellite systems. One is the geostationary at a height of 36,000 kilometers. Another is polar sun-synchronous at the heights varying from 700 to 1,000 kilometers, which we call is an Indian remote sensing satellite system. And this is Indian national satellite. So we all know that when we are talking about the INSAT, we are talking about different applications which are having the geostationary nature. And when we are talking about the IRS, we are basically talking about the natural resources mapping and management. So we will be discussing one by one that how and where we apply that. But as you all might be aware that when we are talking about the space program or any program, there must be a dedicated responsibility to a dedicated center. You might have heard the English saying that too many cooks spoil the broth. हमारे हरियाणा में कहावत है कि कई मामाओं का भांजा भूखा रह जाता है, right? So you have to give the accountable, you have to give the responsibility, then only they will be accountable, right? So as you see here that Ahmedabad, we are having the Space Application Center, we are having the Physical Research Laboratory, we are having the Development and Educational Communication Unit. So all the sensor fabrication that in the satellite, what will be the resolution? I request all the participants to keep their mics mute.
सर आपका ऑडियो म्यूट हो गया है, आप एक बार अनम्यूट कर लीजिए।
Has muted me. Actually, I have not, because I was into the program. So I request that nobody should mute my. I mean, there may be some person who is controlling
sorry,
it.
Sir,
so I request
sorry,
not
sir,
to
there is
mute,
some technical
please.
glitch. Okay, sorry.
Yeah. Okay. No problem. So am I audible now?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Thank you. So
yes, sir. Yes, sir. Totally.
we are having the different centers which are given the dedicated responsibility. So now as you see on your screen that how the launching vehicles came into the existence. So India started with a very, experimental launching of the rocket in 1972. And then India in 1979 came up with the satellite launch vehicle whose weight was 17 tons, and it can carry 40 kg satellite into low Earth observation orbit. Then again improvements was made. Then you came up with ASLV, Indian Space Research Organization, augmented satellite launch vehicle. Weight of the satellite launch vehicle was 39 ton. It can carry a satellite of 150 kg or a group of satellite into low Earth observation orbit. Then came PSLV, Polar Satellite Launch Vehicle in 1993, and then GSLV came in 2001. You all might be aware that after the Pokhran explosion in 1998, then ISRO was put into the blacklist. ISRO was to come up with the fabrication of geostationary satellite launch vehicle in 1999. But because the ISRO was having a closer cooperation with the USSR, and then the problem was that the USSR was, after the putting ISRO into the blacklist, there was a problem in the technology transfer from the USSR. So then Indian Space Research Organization scientists at their own were able to develop the cryogenic stage of the geostationary satellite launch vehicle, and they were able to successfully come up with 2001. So you know now that India is able to launch the range of satellites ranging from the polar, that is 700 to 1000 kilometer, to geotransfer orbit to 36,000 kilometer, to interplanetary missions, जैसा कि आपने देखा है, in the form of Moon and Mars, Chandrayaan and the Mars mission. So this is the day, my dear friends, when India got an acclaimed feat, and it was the world record on February 15, 2017, when India launched 104 satellites in single launch vehicle, right? So I would like to say that in these satellites, about 96 satellites were from the American companies, two companies of America. Out of these 104, 96 satellites were from them. So the country which was criticizing India was not criticizing because they were a sort of well-wisher, but they were criticizing because once India is venturing into the space program, then India will get the efficiency and the efficacy with required capabilities to launch the foreign satellites also. So in that way, the market of launching the foreign satellites will shift from United States of America to India, and India will be earning huge revenue by launching these satellites. So that is another aspect of these type of the programs. We all know that when we are talking about the insect, it was humbly started with the launch of Apple, and then you might be knowing that on 17th of this month, February, we are having the launch of Insat 3DS, right? And you all know that these are multi-purpose satellites. What for? You can see here that when we are having these Insat satellites into the orbit, all our direct to home services, आप टेलीविजन की बात करते हैं, broadcast television broadcasting, direct to home services, TV and radio networking, we are talking about meteorological forecast. You might recall that when you were young, even the Indian Meteorological Department forecasting went wrong. But now you can see your smartphone, and even the hourly forecasting are almost 90+% accuracy. Then you are having the speech circuits. For example, today I'm able to talk to you through these devices, virtual meeting, and this is because we are having the facilities in the form of the speech circuits. And then we are having the developmental applications, telehealth, teleeducation, emergency communication, and we are having mobile satellite services, search and rescue, satellite navigation, etc., etc. So these are some of the applications. I will be discussing one or two which are having the wider national importance. So as you see here that India is the only country which is having a dedicated satellite in the name of EduSat. It was launched on 20th of September 2004, and Dr. APJ Abdul Kalam, he was the man behind this mission, and he was of the opinion that not in every place we are having the certified, qualified and quality resources. So can we use the satellite technology to provide the best material and the resources in the form of the teachers to the students of the government colleges, government schools, or the people who are in the far-flung areas. So I think this is one of the wonderful application of ISRO. Another is when we are talking about the telemedicine, and we all have seen that during Corona, India was able to come up and fought it in a successful manner only because of the digitalization of the things. And now we are having almost all the district and the rural hospitals and the super specialty hospitals, they are connected together. So if there is any problem when the doctor is doing the operation or treating, he can get the real-time help from the super specialty hospital experts, and then he can go ahead with that operation or that diagnosis. So this is where we are now, and the idea behind was reaching to the unreached. And you all might be knowing that all these type of the devices in the form of Corona Kavach, right? And the Arogya Setu app, these are working on the principle by using the locational data from the global positioning system. So another group of satellite, as I was discussing with you, is the Indian Remote Sensing Satellite, IRS. It was also had a very humble beginning in the form of Bhaskar in 1979. And today, when we are talking about, we are having Cartosat 3 satellite into the orbit. So since 1999, you are having about 345 foreign satellites which have been launched from 34 different countries which are there in the form of success of ISRO. So not to go into much of the details, just try to see the red and the black. So wherever red is there, there is a success. And wherever black is there, it was a sort of failure. But we can see that from 1997 onwards, every time ISRO is launching a mission, it is a success. So that is how the market is shifting for launching of the foreign satellites to India instead of any other country. These are some of the satellite launches in 2019, 20, 21, 22, 23. You all might be knowing about the Chandrayaan 3 and the Aditya L1 mission, I think, which are a great success of 2023. But when we are talking about 2024, the beginning of the year, on January 1 itself, India launched X-ray polarimeter satellite. That was in the form of ExpoSat to study the different, you can say, characteristics of the atmosphere. And just a week before, you see on your screen that we had on February 17, 2024, from Sriharikota, there was a launch of INTSAT 3DS through GSLV, Geostationary Satellite Launch Vehicle F-14. And you all might be aware, just to brief about, that INSAT satellites are helping us not only in the oceanic observations, but also in the form of environmental issues and meteorological forecasting. So these are taking information and disseminating information about the vertical profile of various meteorological parameters of the atmosphere, and then to provide the data collection and data dissemination capabilities. And then we are having to provide the satellite aided search and rescue services. So these are few of the very important applications where we are moving in the direction of when India will be further refining its services. So when I'm talking about the Earth observation satellites, we are having the remote sensing satellites into the orbit. And as I was talking to you, that Cartosat 1 and Cartosat 2. And with Cartosat 3, which was launched recently, India is having the imaging capabilities to the tune of 25 centimeters, meaning thereby that anything which is available on the surface of the Earth of the size of 25 centimeter by 25 centimeter can be picked up by this satellite. So box size of thing. Because many of the participants are students, that is why I am focusing more in that direction. As you see here, the problem with the satellite, IRS and Cartosat was that if the clouds are there, these cannot penetrate. They cannot, because the shadow will be there, so they will not be able to. The visible and the near infrared will not be able to penetrate. Then Indian Space Research Organization came up with the active satellite. Active, that is microwave satellite in the form of radar imaging satellite, means RESAT. So India has the beginning in 2009, and now in 2022 also they launched RESAT 1A, and you will be happy to know that these satellites are operating in the microwave region, 1 millimeter to 1 meter wavelength. And these satellites are having the capabilities to penetrate through the cloud. So even if the cloudy cyclones are there, these satellites are getting the pictures of the surface of the Earth. So if the flooding is there, which is associated with the cyclone, you can have the better monitoring. So now India is having, similarly like the launch vehicles, now you are having the capabilities of all weather capabilities. So now the capabilities are that you want to have just a reconnaissance type of information. Where are the glaciated region? Where is the desert? Where is the vegetation? To getting some detailed information with 70 to a 56 meter coming to less than 1 meter, that is 25 centimeter by 25 centimeter, for the civil engineers to go for the street level mapping, for the utilities mapping, and go for the urban areas mapping in the form of the programs which are coming in the form of the smart cities. You all might be knowing that Government of India is having a very important and ambitious scheme. So you are having the applications there. So second very important component is the global positioning system. As of now, we were having the global positioning system controlled by United States of America. And it is having 6 orbital plane, 4 satellite in each orbital plane. And the idea behind was that if you are having a smartphone in your hand, you must have access to at least 4 satellites. Why 4? So X, Y, and G, that is latitude, longitude, and altitude. These are the 3 variables, and 4th is for the time correction. But there was a problem during the Kargil war. the Indian military was not getting the precise locational information. So then India, during the tenure, came up with its own initiative in the form of Gagan. Gagan is GPS and geo augmented navigation, right? And it is spearheaded by Indian Space Research Organization and Airports Authority of India. And you can see that the idea behind having this into the orbit was that we are having a group of 7 satellites. As you see here, 1, 2, 3, 4, 5, 6, and 7. So you are having a group of 7 satellites which has been launched by India. It was started in 2013 by the then Prime Minister Manmohan Singh, and it is continuing now. And with this, you are having the precise locational information not only within India but 1500 kilometers beyond the borders of India, right? So the idea behind this scheme was that when we are talking about that we are going to have these type of the information which is going to help us in the form of the NAVIC. What do we mean by NAVIC? NAVIC is navigation with Indian constellation. Navigation with Indian constellation. So this IRNSS satellite which you are having in the orbit, these are helping not only in the location of the fisherman's boat, but also giving them the SMS, that is in the form of an alert in the morning that where you can find a fishing zone. Why you want to give this type of the information? The idea behind is that we are having the OceanSat type of the satellite. And through these satellites, we can identify where are the fishing zones. How? Because the color of the sea, where the planktons are there, the algae is there, where our fishes are rearing, is having a different color in comparison to the other area. So, INCOIS is a Ministry of Earth Sciences department. They are giving the SMS about the potential fishing zone, that this is the area you can go for the fishing today, right? And then the fishermen are also getting the warning and the alerts for the cyclone, high waves, and the tsunami. And one of the important issues and the problem was that many times fisherman was not knowing that he has crossed the international maritime boundary. So this will also, when the fisherman boat is approaching the international border, then it will get an alert that you are near to the international border, right? So this is the real-time application which is being done in the field. So another very important aspect is the ICT, that is the information and communication technology, right? So when you are combining all these together, remote sensing, GIS, GPS, and information and communication technology, and all you civil engineers, most of the today's participants and other students from the engineering branches, they know that India is second to none as far as the space technology, information and communication technology is concerned. So the advantage of the geospatial technology has doubled with the capabilities of information and communication technology, and we can get the real-time help from the different sources. So how this geospatial technology is helping in the sustainable development goal? You all might be aware that we are having 17 sustainable development goals ranging from no poverty, zero hunger, good health, quality education, gender equality, clean water and sanitation, affordable clean energy, and so on and so forth. So when we are talking about all these issues, climate action, life below water, life on land, so this is having a very important Indian Space Research Organization application to it, even when we are talking about the sustainable cities and the communities, right? So that is how the Indian Space Research Organization is helping us. So before that, in 2008 also, as you see here, that India has made a world record by launching 10 satellites, but now we have already launched 104, so no more discussion on that. So now what happened, that India thought, as there is a, the basic Indian heritage that we talk about Vasudhaiv Kutumbakam. So India thought that we must have a SARC satellite into the orbit so that all the South Asian countries, SARC countries, can utilize that. But Pakistan did not agree. Then it was renamed because if all the partner countries does not agree, then we cannot name it as SAT. So it was renamed as South Asian Satellite. So South Asian Satellite, as you see, was launched on May 5, 2017. And you can see that it was, the data from this satellite is available to all the South Asian countries in a complementary manner so that the resources which are a common good for the future, and we are now talking about the sustainability, must be ensured. Not only it cannot be ensured by a single actor, so it has to be ensured by everyone. So you are having the data which is available to each and everyone. So this was another when India had its 100th successful mission, ISRO, Indian Space Research Organization. In 2012, as you see here, India has the successful 100th ISRO mission. So these are some of the snapshots. In 2013, you were having the IRNSS, Indian Regional Navigation Satellite System, which came into the orbit, and you are having the Gagan and the Inkois-based Navik in place. As you see here, when your program has become such a wonderful in the form of that you are having all weather capabilities, you can launch a group of satellites, not only polar, but also the geostationary satellites. You are having your own positional satellite in the form of IRNS, Gagan and Navik, and then you are having the information and communication technology. So there is a saying, because you all are from science, that science leads to exploration and exploration leads to science. So as you see here on your screen, that India thought that we must venture into the interplanetary missions. So the first mission India tried was on October 22, 2008 in the form of Chandrayaan-1. And my dear friends, you will be happy to know that in the first instance itself, it was a success. And final idea was that you are going to have a satellite which will revolve around the moon, right? So an interesting thing was that there was a piggyback robot in the form of Moon Impact Probe, MIP. And on 14th of November 2008, that Moon Impact Probe was allowed to detach from this satellite piggyback robot, and then it was to, it was had a landing on the moon. It was having a tricolor wrapped to that, and you can see that why you want to have that. Many times question comes, what is the need? The need is you want to have the three-dimensional mapping of the moon. You want to know that how the terrain is there. What are the different spectral composition, means वहाँ पे जो elemental composition है उसके लिए आपको हाइपर स्पेक्ट्रल इमेजर की जरूरत पड़ती है, ल्यूनर रेंजर की जरूरत पड़ती है, आपको लो एनर्जी एंड हाई एनर्जी एक्सरे स्पेक्ट्रोमीटर की जरूरत पड़ती है, जिससे कि आपको ये पता लग सके कि वहाँ पे एलिमेंटल कंपोजिशन क्या है. तो ये आपने 2008 में शुरू किया था, और ये 2008 के सैटेलाइट जो चंद्रयान-1 है उसी से ली गई फोटो है चंद्रयान की. इफ यू सी द सरफेस ऑफ द मून, आप सभी you all might be knowing that whenever there is something beautiful, we always compare it with the moon, right? But if you see on your screen that the surface of the moon is not really so beautiful, it is having lot many scars. Means if there is a meteorite impact, it will remain in the form of a scar, in the form of a depression there, because there is no peniplanation forces. What do I mean by peniplanation forces? That Earth is continuously, having two type of forces. One is the endogenic, another is the exogenic. So endogenic is creating the relief, exogenic is leveling the relief, right? But on the moon we don't have these exogenic forces, so there is no leveling of the relief. इसका क्या मतलब हुआ? It means that if once a depression is made, it will remain depression. So the craters are remaining craters, and the rills you see here are remaining the rills. So we are, whatever the surface is there, if once the scar is made, it will remain the scar. So this is one of the snaps from the terrain mapping camera. And then, my dear friends, in 2019, ISRO came up with Chandrayaan-2. You all might be knowing, and many believe that Chandrayaan-2 was a failure. But I always say that it was not a failure, it was a 75% success. Why so? because only the Vikram lander and the Pragyan rover, when they were having the soft landing, it could not succeed. So only that component of Chandrayaan 2 was a failure. But you were having a orbiter. Orbiter, जैसे हम IRS satellite की बात करते हैं, तो you were having the orbiter which was and which is continuously revolving around the moon. And the beautiful part is that whatever we are having now, the success in the form of Chandrayaan 3. I request all to please mute your mics and don't mute my mic, please. So, when we are talking about all these things, you all know that we are having different payloads which are there. Before I proceed further, I would like to tell you two, three things about Chandrayaan 2. What success we are seeing today in the form of Chandrayaan 3? The area where we have to land the Vikram and the Pragyan rover this time, it was identified with the help of Chandrayaan 2 orbiter. Previously, when the landing was there for Chandrayaan 2, it was 0.5 kilometer by 0.5 kilometer area. But can you believe this time the area was about 2.5 kilometer by 5 kilometer area or 4 kilometer area in which the lander could have landed anywhere. One. Another is that you were able to identify that in the previous Chandrayaan 2, there were five different boosters, right? And there was no communication between each other. There was a failure, software failure in Chandrayaan 2, and because of that, there was a higher thrust by one thruster. It could not be recognized by the another one. But this time you were having only four, and these were self-learning. That if there is more thrust from one booster, then correspondingly the other booster will equalize it, right? So that is another idea. And third component was that why we are a success, as you all know, that we learn from the failures. And the other failure was that even if everything, whatever we are thinking and deciding goes wrong, even then there could be a successful landing that was in the form of a redundancy component. So all you know now that we are having Chandrayaan 3, and Chandrayaan 3 was a huge success. And I must congratulate each and every one of you that India is the only country which is having a successful landing on the South Pole, successful, smooth, and the soft landing, right? So India is the only country till now. So it was with a mission life of one lunar day, meaning one lunar day is equal to 14 days on the surface of the Earth. And when it was landed, its touch down speed was 0.5 meter per second, and the horizontal and the vertical speed were 2 meter per second, and the altitude was 100 meters. I know that many of you might have seen the live demo of the landing, and at a altitude of 100 meters, there was little bit that lander, it was hovering. So it took few seconds before it started landing. The idea was that if there is not a desired place which was previously identified, there is some problem in that, it can, with the help of the return, you can say, waves, it can identify that which is a smooth area nearby. So it could have shifted itself and landed there. So that those were some of the things which were learned from the failure of Chandrayaan 2. Now it is consisting, जो लैंडर है, it is consisting of 3 payloads. इसके ऊपर 3 अलग-अलग सेंसर लगे हुए थे. First payload is Rambha, that is radio anatomy of moon-bound hypersensitive ionosphere and atmospheric Langmuir probes to understand the hypersensitive ionosphere and atmosphere of the moon. One. Second was to do the thermophysical experiment, and the next was just like the earthquakes, we are having the moon quakes on the moon. जैसे earthquake है अर्थ के ऊपर, we are having the moonquakes. So moonquakes, to understand those moonquakes, we are having a instrument named as ILSA, instrument for lunar seismic activity. So this is another very important payload into this. So then we are having a rover. Rover was that when the lander is there, then after some time the Pragyan will come out of that, and then this Pragyan rover was having 2 important components, payloads. or you can say the instruments, one in the form of APXSC, APXS, and another was LIBS. This was alpha particle X-ray spectrometer and laser-induced breakdown spectroscope. The idea behind is that what is the elemental composition of the crust of the moon. So whether we can identify what is the percentage magnesium, aluminum, silicon, potassium, calcium, titanium, iron, in addition to, as you all might be knowing, that we were having one of the important aim, that presence of water on the moon surface. And then, I mean, it was quite interesting. Just to tell you that when the rover was moving, then you're having this instrument which was coming down, and it was having just few centimeter difference between the moon surface. And it is because there only you can have these X-ray spectrometer record its reading. And then as it was moving, it was taking the readings of the surface of the Earth. Quite interesting. So you can see that when we are talking about the moon, how these photographs indicate the presence. Earth has viewed by the lander imager camera of Chandrayaan-3, not a very high resolution. Depends on that what is your aim. And then you all know that India has a huge success on September 2, 2023, just 3 days before the Teachers' Day. And it was in the form of Aditya L1 mission. Aditya L1 mission, as the name indicates, that it was the mission to Sun, Aditya. And the idea behind was that we want to study the chromosphere, corona, and the process of coronal mass ejection and the solar flares, right? So that how the sun is having the different phenomena which are taking place, and then how it is affecting the, you can say, the weather on the surface of the Earth. That was also very, very important aspect. And there was also a magnetic field topology and magnetic field measurements, right? So when we are talking about the Aditya L1, the idea behind was that we are launching this Aditya L1 to a place from where there is no occult hindrance. Occult hindrance, okay, it will be able to see the surface of the sun 24 into 7 into 365. So whatever is taking place on the surface of the sun, it is recording. So if there is a coronal mass ejection, so it is recording that. You all might be knowing that we talk about dark spots on the sun, and it is having a frequency of 11 years, right? So how this is being created, right? So we are having these points L1 where the force of attraction from the sun and the earth are equalized in such a way that these are providing necessary centripetal force to the object which is placed at L1. And it doesn't require much of the external power, and then it will remain in that position itself. So that is the Lagrange point 1. So like this, we are having 5 different Lagrange points. And as we all know that it is the distance between the L1 and the Earth is about 1.5 million kilometers. So when we are talking about the payloads, because when you are launching it, then you are having instruments which are present over there. So out of these instruments, 4 instruments are the in situ, 3 are the in situ, and 4 are the remote sensing. I mean, because the Aditya L1 is point L1, and it is having a longer distance to the sun. But from the distance itself, it is recording the information, remote sensing from remote without physical contact, because it cannot reach there, right? So we are recording the information. So we are having 7 instruments which are placed on Aditya L1. Out of these, 4 are on the principle of remote sensing, and 3 are in situ, meaning thereby that these are there on the, I mean, all the instruments are there on this Aditya, but 3 are taking observations nearby, and 7 are recording the information about a distant sun surface, right? So that is also very, very interesting, that at a distance of about 1.5 million kilometers, you are able to get the information about the processes which are taking place on the surface of the moon. So as you see here that Mars orbital mission was another success, and many times people laugh that you were able to launch that mission at a lower cost than you sit in an auto rickshaw, and the per kilometer cost which was there is less than what could have been otherwise. So now we are having, after the success of Mars orbital mission, you can see Prime Minister Narendra Modi congratulating the Indian Space Research Organization scientists on September 24, 2014. This was another very, very important mission. Now move to the anti-satellite missile. Indian Space Research Organization with DRDO, Defense Research Development Organization, you were able to hit a satellite into the low Earth observation on March 27, 2019. Right? So within 3 minutes, the mission was completed. This was another milestone in the history of Indian Space Research Organization. So we have talked a lot about that. What is the scenario as of now, present scenario? So what is the future? As you all might be knowing that when we are launching a mission, we are using the launch vehicle. And the problem of launch vehicle is that in one launch, it fires itself. I mean, it is not available for the next mission. It is burnt in the atmosphere itself. Now the Indian Space Research Organization is planning that instead of the launch vehicle, can we use this type of the reusable space plane? So what you are doing, that you are putting a number of satellites into this space plane. You are taking these to the desired height, launch the satellites, and then you are calling back this space plane. Again, you are refurbishing it. Again, it is getting ready for the next mission. So this is one of the important future mission on which ISRO is working. Second, you might have read in the newspapers today that there is a process of launching the humans into the space, and the mission is known as Gaganyaan. तो ये जो गगनयान है उसमें क्या प्लान किया हुआ है इंडिया ने, that they will be launching 3 members to an orbit of 400 kilometers into the space. They will remain there for 3 days and then they will be brought back to the surface of the earth. So for this, today only the names have been declared yesterday, and the name are 4 astronauts are there as of now. Out of these 4, only 3 will be selected at the end. So first one is the Prasant Balakrishnan Nair. Next is the Angad Pratap, Ajit Krishnan, and Subhanshu Shukla. All are the Sukhoi fighter pilots. Third very important mission is the navigation expansion. जो IRNSS I was talking about, that will be added with 4 more satellites. These are the geostationary satellites, so as you can have the capability to have the information 5,000 kilometers beyond the borders of India. So as of now, as I was telling, that only 1,500 kilometers beyond the borders of India, we can have the precise location, and it can be, the military can use as the precision targets. But with the expansion, you will have the access up to 5,000 kilometers. So we will be more comfortable as far as our defense needs are concerned. This is another very, very important mission which will be launched somewhere in 2025-26, and this is in the form of the DUPEX, where the Japanese and the Indian Space Research Organizations are joining together, right? So LUPEX is Lunar Exploration Mission, and Lunar Exploration Mission is also, we call it as Chandrayaan 4. It is aimed to land 350 kg landers on the darker side of the moon. So now you want to have the heavy landing, right? So you want to develop the precise landing technology with the help of that, and you want to go for sample return mission in the coming time. So this is another. Chandrayaan 3 is not the last one. So you are having the Chandrayaan 4 and the DUPEX. And then you are having the Mangalyaan 2. Mangalyaan 1, you had a success, so you want to go for Mangalyaan 2. Then you are having Shukrayaan in the form of mission to Venus. This is also selected later, 2025. And then this is also very important, that is NISA, NASA and ISRO Synthetic Aperture Radar, right? It is a combination of the NASA and the ISRO venture. So this is another very, very important mission. So these are some of the future missions. So why I was talking to you all about this is these applications. You can see on your screen that when we are talking about the earth observation applications, you talk about nowadays a lot of discussion on precision agriculture, right? Watershed development in the forest to not only understand the forest cover, afforestation, deforestation, biodiversity characterization, environmental impact studies, potential water and the command area management, groundwater, ocean. I have given an example of the helping the fishermen by the space technology, land use, land cover monitoring, and as I was talking about inside 3ds, that weather and climate. So you are having the applications of earth observations into the each and every facet of human life. If I want to say in a very crude manner that there is no facet of our life which does not have the application of space technology, or without the space technology, our life would not have been as comfortable as we are having today. So where to look now? When we are talking about the future geospatial technology, we are going to have more and more sensor-based services. As you all might be knowing about the driverless driving, you all know about the metros working with the driverless technology. You are having the uh, the railway lines being guarded by the sensor-based uh, gates. You are having the buildings in the form of the smart cities. You are having the sensors for the quality monitoring. So with the help of the Internet of Things and the machine learning, we are going to have the life which will be more and more dependent on the locational services. And when I'm talking about the location is the GPS, and that is the base when we are talking about the geospatial technology. So you all are much more aware that when we are talking about the recent trends in the space technology, you are having all that augmented virtual reality, wearable technology, cashless payments, target marketing, geospatial and artificial intelligence. The sensors are becoming, with the passage of time, you are having the micro satellites which are into the orbit, self-driving vehicles, smart cities, right? So your geospatial technology have now become the part and parcel of our daily routine, right? And these trends are going to continue in future also. So many of you are today with us who are the youth and who are looking for the opportunities in the Indian Space Research Organization. So what are the job opportunities and why? ISRO is offering various challenging opportunities which are ranging from the development of innovative technologies to the advanced infrastructure required for space exploration. And you all might be knowing that now many and many of the new startups are coming even in the space field. So they want to have the ISRO is committed to encourage students in creating awareness in the space technology and the applications. Students are the future hopes for applying technologies for the social and economic upliftment of the country. And the basic idea is to provide the young Indians with an opportunity to work on cutting edge technology and contribute to the success in the space exploration. And these have been initiated in the form of, one is Yuvika, that is Yuva Vigyani Karyakram. This is for the young scientist program for the school children, right? This is to impart the basic knowledge about the space technology, space sciences, and space applications to the younger students. This is one of the initiatives. Another is, for example, you are a civil engineer, you are a mechanical engineer, you are an aeronautic engineer. So they are having the direct recruitment through ISRO Centralized Recruitment Board, ICRB. So they are recruiting the scientists and the engineers. So the graduates, that means the engineering graduates and other graduates, they have to appear in the ICRB exams from different branches like electronics, mechanical, electrical, civil, computer science, refrigeration, air conditioning, etc., etc., and etc. Right? So you are having an opportunity that if you are able to score very high in the written exam, you may get the opportunity. And there are also an initiative known as Catch Them Young. So after class 12th, the ISRO is having the Institute of Space Science and Technology in the form of IIST, Indian Institute of Space Science and Technology. It is in Trivandrum, Thiruvananthapuram, specifically for the non-medical students. So that they can go and do their degree from there, and 85% 85 to 90% of these graduates are hired by Indian Space Research Organization. So just I will take 3 or 4 minutes more because I know that I'm approaching the time. So just for your knowledge, you can see on the screen that I'm also involved in these type of books. Me and my co-authors, my colleagues from different universities, we are coming out with the Springer publisher is there. So books in the form of application and challenges of geospatial technology, remote sensing and GI science, and then geostatistics and geospatial technology for groundwater resources in India, because you all might be knowing that when I was talking about the applications in different areas, water is one of the sector which requires lot of innovative technology applications, because in future we are going to be stressed to a huge extent for the availability of groundwater, not only the quantity but also the quality. And then the recent publication towards sustainable natural resources. So now you have to talk, instead of sustainable development, you are talking about sustainability. So with this, I would like to, conclude my talk that Earth has enough for man's need, but not enough for man's greed. It was a famous quote from Mahatma Gandhi, and which was adequately supplemented by Abraham Lincoln. You can see on your screen that you cannot escape the responsibility of tomorrow by avoiding it today. So we have to take the responsibility, or you might recall a saying from Tony Blair that this is the first generation to see the effect of climate change in real life, and probably this is the last generation which can do something to mitigate this climate change. So with this, I'm indeed grateful, as I started my career from Haryana Space Application Center, Hisar, in as early as 1990, and after serving HARSAC, Haryana Space Application Center, for about 14 years, then I joined the Department of Geophysics, Kurukshetra University, Kurukshetra. So my special thanks to ISRO family. And with this, Saeed, I would like to bring my talk to the conclusion, and I would like to, open it for the discussion. If there are some questions in the chat box, or if there are some questions, whatever way you want to go ahead with this.
Thank you,
So
sir.
I'm stopping the presentation.
Thank you, sir, for such a valuable talk. I request to the students, if you have any queries related to the talk, or apart from the talk related to your career from the future perspective, you can directly put your question to Dr. B.S. Chaudhary, sir.
Good afternoon, sir.
Good afternoon.
Yes, sir. So I wanted to extend my gratitude for the wonderful presentation, sir. It was both very
Thank you.
informative and
Thank you very much,
educational.
Arpan.
Thank
Thank
you
you,
for
Arpan.
sharing your insights with us. Sir, I have a couple of questions if you don't mind.
Please, please.
Yes, sir. So I wanted to inquire about the current biggest challenge and thresholds our Indian space organizations are striving to overcome.
Actually, when we are talking about the developments, so there can be two type of the major challenges. One is the technological, another is the financial. So as far as the financial situation is concerned, the Indian Space Research Organization, we are fortunate that we do not have any ministry under which the Indian Space Research Organization or Department of Space is. So it is directly under the Prime Minister, and we are having a head of ISRO in the form of chairman ISRO, who is a technocrat or an engineer. So whatever political interference could have been there in the form of giving the financial resources, there is no problem of that time. When we are talking about the technological developments, as you all know, that with the passage of time, we are having the continuous advancement in the technology. Advancement in the technology, not only from the Earth observation point of view, but also from the launching point of view, right? So when we are talking about this, we are having a continuous development in the electronics in India also, but at times when we are talking about the international developments, in some of the areas we are better than them, but in some of the areas we require more and more focus. Recently, some of you might have seen that the present chairman, Shiva Kumar, he has specifically mentioned that when we are talking about the quality intake, that if I want to say in a blunt way, that many of the IIT students, the ISRO is not able to recruit because of the low pay packages. And those are going to some international organizations. So this was one of the area where he has raised a sorry, it's not Shiv Kumar, Somnath. So Somnath raised, ISRO chairman Somnath, he has raised that we are not able to recruit because of these issues. So probably maybe in the coming time we are having the better remunerative pay packages. So there will not be any debt for the talented graduates to be inducted into the ISRO. So I think this is the situation as of now. Arpan, if there is another question, please.
Yes, sir. I wanted to also inquire about if there are any programs to say engage and inspire students in the field of space exploration. So I just wanted to inquire about that.
Yeah, sure. Arpan, I would suggest that you go to the ISRO website today itself, and they are having specific programs catering to specific needs. For example, as I was talking about that Catch Them Young, or we are having Yuvika, these are for the schools, but they are having specific programs for the engineering graduates also. And there is one program that is in the form of the residency, 2 months program is there, where you have to you have to apply, and there will be a number of applicants, and through a exam they will be selected, and it will be a 2 months residential program in which the students will be exposed to satellite fabrication कि आप उपग्रह को किस तरह से बना सकते हैं, right? So there are a number of programs in which the ISRO is trying to connect the students.
Yes, sir. Thank you, sir.
Thank you, Arpan. So any other?
Any other?
Saeed, I was just checking the chat. So one of the student has said that whether this PPT will be available. So I will be sending the PDF to you. If somebody is interested, you can share with them.
Okay, sir. Thank you. And if there is anyone have any question or queries, so you can.
Muhammad Jamal, you want to say something? Please unmute yourself and then you can raise a question.
No, sir.
Oh, thank you.
Okay, sir. Thank you.
So I'm able to see the raised hand from Anisha. Anisha Mehti, you want to share something? You have raised the hand. Or Saeed Amir? Any one of you? So Dr. Saeed, I think
Yes, sir.
I'm not able to see many questions, so then we can, yeah, please go ahead.
Okay, sir, and thanks once again for a valuable talk and a journey from the beginning to the future of space program. And it's a wonderful session, and I wish we will call you for the offline session once again in Kolkata, the city of joy, in future. And thank you once again for giving your valuable time. And let we have in near future we will looking for the future collaboration also, because we are working in the water resource domain, and hope we will look into that matter also. Thank you, sir.
Great, Saeed. And I would like to also thank each and everyone, the students who are present here, the colleagues who are present over here. And it will be a pleasure. Please do not hesitate yourself. Sometimes we have the hesitation to putting the questions. So I have put my email ID into the chat box. So you all are free to, if there are any queries or if I can help anyway.
And sir, one more
Thank you
thing,
very much.
till now we have organized lots of session, but we have grateful that n number of students are still waiting for the join, because we have the limited seats. That's why we are not allowed to join them. But in future we will have some discussion, open discussion also. Okay, thank you, sir.
Thank you very much. Have a good day.
Thank you.
Thank you, sir.